At the farthest edge of our solar system, where the sun has become only a brilliant memory and the wind it once blew outward has thinned into something almost imperceptible, Voyager drifts on through a darkness so vast it feels less like empty space than the absence of every familiar rule. It has spent decades moving away from home, carrying a golden record, a handful of instruments, and the quiet persistence of an entire civilization, hoping to understand what lies beyond its own light. And yet, at that boundary, at the place where our cosmic neighborhood is supposed to end, Voyager found something that should not have been there. Not just a surprise, a contradiction, a region where the sun's influence, the interstellar medium, and the very structure of space seem to meet in ways the models had not prepared us for. If you stay with this journey beyond the universe, you will see why that contradiction became more than a footnote in spaceflight history. It became a warning. If you're drawn to questions like this, the kind that slowly unravel everything we thought we understood about reality, then you're already part of Beyond the Universe. And if this journey resonates with you, take a quiet moment to leave a like and subscribe so you don't miss what comes next. Before we can understand the disturbance, we have to understand the promise that was broken. For decades, scientists imagined the outer solar system as a kind of gradual surrender, a place where the solar wind would slow, compress, and finally lose its authority against the thin but relentless pressure of interstellar space. The picture looked clean on paper, the sun's particles streaming outward in a bubble, the heliosphere acting as a protective shell, and beyond it, the heliopause, a boundary where solar influence would fade into the galactic ocean. Voyager was sent not to prove this picture poetic, but to test whether it was real. The expectation was elegant. The reality was stranger. When Voyager reached the edge, it did not simply cross a frontier. It encountered a region behaving like a wound in the model, a place where charged particles, magnetic fields, and cosmic rays told a story that was almost, but not quite, the one we thought we knew. Something had changed out there, or perhaps something had never been understood in the first place. To appreciate the scale of that problem, you have to picture the sun not as a distant star, but as a machine of motion. It constantly emits a stream of charged particles, the solar wind, launching protons, electrons, and embedded magnetic fields into space at hundreds of kilometers per second. This flow inflates a bubble around the solar system, a heliosphere so enormous that Earth sits deep inside it, shielded from much of the harsher radiation between the stars. For a long time, the outer edge of this bubble was imagined as a kind of calm border, a soft transition between the sun's domain and the galaxies. But space is rarely soft. Space is a collision of pressures, and wherever pressure meets pressure, nature draws boundaries that are anything but simple. Voyager did not find simplicity. It found turbulence, asymmetry, and a boundary that seemed to breathe differently depending on direction, as if the heliosphere itself were shaped by forces far more complex than any neat sketch could contain. When the Voyager probes launched in 1977, they were not built as philosophical instruments. They were machines of measurement, practical and patient, designed to answer a simple question: what is out there? Voyager 1 and Voyager 2 traveled outward through the giant planets, revealing volcanism on Io, storms on Jupiter, the icy architecture of Saturn, the hidden physics of distant moons. Then their mission changed. Long after the planets were behind them, the spacecraft kept going, and the farther they went, the more they became messengers from a region no human hand could ever reach. Their data traveled home across the deep cold, and each packet of information carried with it a strange duality, a confirmation of physics and an invitation to doubt. The outer solar system was not empty. It was active, layered, and alive with interactions we could only infer from a distance. And when the probes neared the heliopause, those interactions became unsettlingly personal, as though humanity had pressed its ear against the universe and heard a voice answering from the other side. Scientists had expected that crossing the edge of the heliosphere would look like crossing a line in a map, an incremental change, a measurable but orderly transition. Instead, Voyager found a region that behaved more like a negotiation. Charged particles slowed, accelerated, and deflected in surprising ways. The magnetic field did not twist quite as expected. Cosmic rays, those high-energy particles arriving from the galaxy, increased sharply as the sun's shielding weakened. But the most unnerving part was not that a few numbers differed from prediction. It was that the differences revealed the boundary was not a clean wall at all. It was a dynamic interface, a place where solar and interstellar plasmas interpenetrated through a complicated dance of pressure, magnetism, and diffusion. In other words, the edge of the solar system was not an edge in the ordinary sense. It was a system within a system, And that realization opened a deeper problem. If the boundary we imagined was wrong, what else about our cosmic map was only an approximation we had grown emotionally attached to? The first great revelation came from the shock of the solar wind itself. Voyager recorded a dramatic slowdown as it approached the heliopause, the outward flow losing momentum in response to the resistance of interstellar space. For years, researchers had anticipated this, but not at the exact scale or configuration observed. The termination shock, where the solar wind abruptly decelerates from supersonic to subsonic speeds, was not a neat, static surface. It rippled, it moved. It seemed to vary with the sun's activity, the direction of travel, and the invisible geometry of magnetic fields stretching across the boundary. This mattered because the solar system is not a sealed bubble in a vacuum. It is a living interaction between the sun and the galaxy, and Voyager showed that the outermost layers of that interaction are more unstable than expected. The implication was quietly dramatic. The sun does not command the edge of its realm with certainty. It only participates in a larger contest, one where the galaxy is always pressing inward. Then came the magnetic surprise. One of the most puzzling results from Voyager's journey beyond the heliopause was that the magnetic field just outside the boundary appeared, in broad terms, unexpectedly aligned with the field just inside it. Many scientists had anticipated a sharper change, a visible reorientation that would signal a complete shift from solar-dominated magnetism to interstellar dominance. Instead, the transition was subtle enough to provoke debate, and that debate quickly became a reminder of how limited our vantage point truly is. If the magnetic field near the edge of the solar system is not behaving in the way the simplest models predicted, then the outer heliosphere may be shaped by structures we cannot easily see: the local interstellar magnetic field, the plasma environment around the sun, and perhaps even the sun's own long-term passage through the galaxy. The contradiction was not only observational, it was conceptual. The boundary existed, but not as a line we could draw with confidence. It existed as something more fluid, more braided, and more difficult to name. And then the cosmic rays arrived like a message from outside the wall. As Voyager moved farther into interstellar space, the intensity of galactic cosmic rays increased, confirming that the sun's shield had weakened and that particles accelerated by distant supernovae, pulsars, and other violent astrophysical engines were now reaching the spacecraft with less obstruction. That might sound like a routine confirmation of boundary crossing, but it carried a strange emotional charge. For most of human history, the sky above us looked fixed and serene. Yet here was evidence that the space between stars is being constantly traversed by high-energy debris from ancient explosions, invisible bullets of matter, and energy racing through the galaxy at nearly the speed of light. Voyager was not just leaving home. It was entering an environment shaped by the death throes of other stars. In that sense, the edge of the solar system was not a frontier between safety and danger. It was the point where one stellar story dissolves into the turbulence left behind by countless others. By now, the pattern begins to emerge. Model, discovery, contradiction. Scientists imagined a bubble. Voyager found a structure with seams. Scientists expected a firm boundary. Voyager detected a layered transition. Scientists assumed the heliosphere's outer shell would be governed primarily by solar conditions. Voyager showed that the interstellar medium was not a passive backdrop, but an active participant, imposing its own geometry on the sun's reach. Every answer widened the question, and that is what makes Voyager's data so haunting. It does not merely tell us what lies beyond the solar system. It reveals how much of that beyond is still governed by interactions we can describe only in fragments, using formulas that are strong enough to predict, but not yet strong enough to fully explain. This is where awe begins to curdle into unease, because the universe does not simply hide its secrets. Sometimes it hands us just enough information to prove our confidence was premature. At first, the heliosphere was imagined as a kind of protective cocoon, a cosmic shield that insulated the planets from the harsher environment of the galaxy. That metaphor remains useful, but Voyager forced it to become more precise. A cocoon is static. The heliosphere is not. Its shape depends on the solar wind's pressure, the motion of the sun through the local interstellar cloud, the strength and direction of magnetic fields, and the density of neutral particles flowing through surrounding space. It may be compressed on one side and stretched on another. It may breathe with the 11-year solar cycle. It may even respond to structures in the interstellar medium we have only just begun to map. And so the boundary at the edge of the solar system is not just a border, it is a forecast of the future. a place where the sun's evolving environment meets the galaxy's broader architecture. Voyager, in its silence and persistence, has become the instrument by which we learn that our home is not finished. It is still being shaped. There is something deeply unsettling about that idea. We prefer to imagine the solar system as stable, its major structures long since settled into place. But if the edge is dynamic, then the environment around us is dynamic. If the heliosphere changes, then the cosmic radiation environment near Earth can change too, slowly altering the background conditions under which life exists. This is not science fiction. It is the practical consequence of astrophysics. The solar system is not isolated from the galaxy. It is embedded in it, and Voyager's observations make that embedding impossible to ignore. We live inside a bubble that is both shelter and interface, a structure whose shape is negotiated by forces far beyond our control. The implication is subtle but profound. Humanity is not standing outside the universe, looking in. We are suspended within a flowing, shifting relation between one star and the larger galactic medium, and our idea of outside was always a simplification. But the most dramatic part of Voyager's story is not that the spacecraft crossed a boundary. It is what happened to our certainty when it did. For decades, scientists could model the outer heliosphere using equations that worked remarkably well, yet the data kept revealing details that the equations treated too gently or too crudely. Some of the irregularities were technical. Some were the result of sampling a wildly complex region from only two tiny points in an immense frontier. But some of them were genuine physical surprises, evidence that the local interstellar environment and the heliosphere interact through mechanisms that resist oversimplified description. That is the hidden contradiction at the heart of the story. The farther we go from the sun, the more we learn that edge is not a singular idea. There are plasma boundaries, particle boundaries, magnetic boundaries, and conceptual boundaries, each with its own behavior. Voyager did not reach the end of the solar system. It reached the beginning of a deeper uncertainty. The spacecraft itself makes this hard to accept because it feels so small compared to what it has taught us. Voyager is an artifact from another era, a machine built with 1970s technology, now billions of miles from Earth, still speaking in a narrow electronic whisper. It carries no drama in its design, no cinematic engines, no symbolic ambition beyond the sober dignity of measurement. And yet its data has forced modern astrophysics to confront a boundary where the sun's influence fades into the broader galactic environment in ways that are neither simple nor fully uniform. This matters because science often advances by drawing clean lines between known and unknown, but the edge of the solar system seems determined to erase clean lines. It is neither fully inside nor fully outside. It is a region of transition, and transition is where models become vulnerable. The universe, at least here, does not respect our desire for crisp categories. Consider the scale of what this means. If a boundary this vast can remain partially mysterious despite decades of observation, then the problem is not merely distance. It is epistemology. It is the fact that our instruments, no matter how advanced, only translate the universe into fragments of readable behavior. Voyager's instruments can count particles, measure fields, and detect changes in plasma density, but they cannot directly show us the total architecture of the heliosphere. They sample it, they infer it, they suggest its contours the way a blind hand might infer the shape of a statue by touch alone. And so each new reading becomes both revelation and limitation, evidence and confession. We know more than before, and at the same time we are forced to admit how much of the map is still drawn by educated imagination. That admission is not failure, it is the price of looking honestly at the edge. In the next part of this journey, the story deepens beyond the boundary itself, because Voyager's greatest gift is not merely that it crossed into interstellar space, but that it turned the abstract concept of interstellar into something measurable, something with texture, pressure, and chemical identity. Once we understand what it found there, the contradiction grows sharper, and the question changes. It is no longer just what lies beyond the solar system. It becomes this: if the space between stars is stranger and more structured than expected, then what else about the universe have we mistaken for emptiness simply because we could not yet see its contents? As you begin to grasp Voyager's crossing into interstellar space, you must imagine not just a boundary, but a liminal zone, a threshold between worlds that defies the neat divisions we crave. The interstellar medium itself, once thought to be sparse and relatively uniform, is now revealed as a mosaic of clouds, ions, dust, and magnetism, each thread weaving its own pattern into the fabric of space. Voyager's instruments captured variations in particle density and direction that suggested nearby interstellar clouds colliding and merging in unseen cosmic choreography. This means that even beyond the heliosphere, the universe is anything but empty or static. Instead, it is an energetic environment, alive with flows and fields that challenge our definitions of space. Far from the quiet vacuum we once imagined, these are turbulent waters through which our spacecraft glides, a complexity that forces us to rethink where the solar system ends and the galaxy begins. That very rethinking indicates something profoundly disturbing. Our mental models, those elegant frameworks of astrophysics that have propelled exploration so far, rely heavily on simplification. The universe is rewritten as a system of boundaries and interactions we can calculate. But at Voyager's edge, reality stubbornly resists that neatness. The interstellar magnetic field we once imagined as uniform and gently curved now appears patchy and twisted, almost pleading against the simplifications used to describe it. Voyager's magnetometer data reveal magnetic folds and kinks, whose scale and persistence defy simple explanation. This magnetic tapestry is not a passive backdrop. It actively shapes the passage of solar particles, cosmic rays, and even the diffusion of dust. Each twist in the field challenges our capacity to predict how these invisible forces connect star to star, system to system. The contradiction here is sharp. Our best tools show us a universe whose complexity outstrips our categories, a universe perhaps too fluid and entangled to ever be fully contained by equations alone. Looking beyond, the cosmic ray data deliver their own jarring message. Voyager recorded unexplained fluctuations in cosmic ray intensity, suggesting that the galaxy's particle environment near our solar system is far more dynamic over time than previously thought. Rather than a constant, spatially uniform ocean of high-energy particles, cosmic rays appear to be modulated by structure in the galactic magnetic field and by the shape of the heliosphere itself, which acts not just as a shield, but as a variable filter. This means the radiation hitting Earth is not a steady rain, but a shifting gale, influenced by events both close and far. Supernova remnants, pulsar winds, and interstellar shocks ripple through space, altering the flux of particles on timescales ranging from years to millennia. This subtle but profound variability complicates the notion that the space environment near Earth is normal, suggesting instead a cosmic weather system whose rhythms we are just beginning to discern, and that could affect life and technology itself. These revelations force you to consider humanity's place in this cosmic arena with new humility. Voyager, a technological child of the 20th century, has become a bridge, carrying our curiosity into spaces more alien than any ocean or desert. But what it has uncovered is less a simple frontier for expansion than a fractal zone of interactions, nested realities where solar power fades and interstellar influence waxes, some measurable and calculable, some stubbornly ambiguous. The neat boundaries we place on the solar system dissolve into gradients of influence, fields of energy, and shifting currents of matter. You begin to realize that the universe beyond is not a static vacuum, but a complex cosmos in motion, reflecting not only the behavior of stars and gas, but the limits of comprehension itself. Voyager does not just measure space, it exposes the limits of human understanding, revealing that the more we explore, the more epistemological unease grows. The physical discoveries bring forth another crisis, one of interpretation. For decades, the heliosphere was modeled mostly as a symmetric bubble, gradually shaped by the solar wind pushing uniformly against the interstellar medium. Voyager's data dismantled that simplicity. The southern hemisphere and northern hemisphere of the heliosphere are not mirror images. Instead, they reveal asymmetries caused by the orientation and pressure of the local interstellar magnetic field. These asymmetries cause the heliopause, the solar boundary, to shape into a form more like a comet's tail or a distorted bubble, stretched and compressed in directions choreographed by cosmic forces outside our solar system. This undermines the assumption that the sun's influence dominates in all directions equally. The implication is that the heliosphere is a reactive, shaped entity, molded by local galactic conditions invisible to us but far from negligible. This means that every planet, every comet, every far-flung fragment inside this bubble experiences a uniquely dynamic environment that evolves in concert with our motion through the galaxy. With each new layer of detail, the contradiction tightens like a noose. The boundary we call the heliopause is not fixed. It pulsates with the solar cycle, modulated by variations in solar wind pressure, yet also responds to fluctuations in the interstellar medium. Voyager's environmental readings capture waves and ripples not predicted by earlier models. Magnetohydrodynamic shocks, turbulence, and unexpected particle flows that transform this frontier from a placid divide into a war zone of plasma and magnetism. You imagine the solar system's edge not as a quiet shell, but as a boundary in constant combat, a battleground shaped by invisible forces. It is an uneasy reminder that while we define our cosmic zone by where the sun's influence ends, that ending is never certain, never calm, never complete. This volatile interface has profound consequences beyond mere description. It means that the solar system's protection against cosmic radiation is neither stable nor guaranteed. When the heliosphere compresses or weakens, more galactic cosmic rays pierce its boundary, increasing radiation exposure to planets within, including Earth. Such changes can influence planetary atmospheres, climate patterns, and even biological evolution over geological timescales. Astronomers and astrobiologists are beginning to consider that shifts in the heliosphere's shape and strength could be correlated with mass extinctions and genetic mutations on Earth. We are situated within a cosmic context that is active, fluctuating, and influential, parameters not usually accounted for in traditional models of Earth's history. Voyager's data forces a sobering perspective. Humanity's well-being might partially hinge on the unseen and changing shape of a boundary nearly 1 trillion kilometers away. But the unease runs deeper still once we step beyond the edges of the solar system into the unfolding galactic environment itself. Voyager's crossing was not an end, but a doorway into a hidden world where vast forces shape the very emptiness and structure of space with greater subtlety and intensity than anticipated. The local interstellar cloud, a tenuous, partially ionized gas through which the sun is currently traveling, is itself a patch in a much larger galactic mosaic woven from clouds, shock fronts, and magnetic fields. Measurements of neutral hydrogen and helium show that the cloud is flowing past the sun at a speed of roughly 26 kilometers per second, colliding with adjacent clouds to form interfaces we scarcely understand. The void is paradoxically crowded, with energy gradients, material fluxes, and magnetic boundaries that challenge our conventional definitions of empty space. Voyager's slow drift through this medium reveals a universe active on scales both enormous and intimate, a kinetic environment shifting beneath human feet and far beyond. That raises an unsettling question. If the local interstellar environment itself is so textured and changeable, how many layers of cosmic structure remain hidden beyond our probing? Voyager offers a glimpse, but the galaxy is both vast and variegated. Magnetic fields wind across thousands of light years. Supernova remnants leave traces in the diffuse gas. Cosmic rays arrive from distant cataclysms we can only imperfectly reconstruct. Every measurement Voyager makes at the edge of the solar system is a tease, data points hinting at larger, more complicated interactions beyond our immediate vision. It is as though, standing at the threshold of interstellar space, you see shadows of grand workings but lack the full light to understand their shape or meaning. The contradiction extends from the local to the cosmic. Our map of the galaxy's influence, its texture, its dynamic breadth, remains tenuous, incomplete, and ultimately disturbing. As you stand with Voyager, suspended in this remote frontier, these ambiguities grow into a philosophical unease about the nature of scientific knowledge itself. Our models rely on observation and extrapolation from limited data sets. Voyager's readings from 2 points in a boundary, spanning billions of kilometers. Scientific frameworks demand that phenomena be consistent, replicable, and predictable. Yet at the edge of the solar system you find inconsistencies challenging repeatability and predictability, not due to human error but because nature itself does not conform neatly. This invites a deeper reflection. Perhaps the universe, like consciousness or life itself, is not entirely reducible to mechanistic description. Our understanding remains partial, layered with assumptions born from hard-won but incomplete glimpses into an unfolding reality. Voyager has become not only a tool of discovery, but also a mirror reflecting our limits, revealing an epistemology that must embrace uncertainty as part of cosmic truth. Here, at the crossroads of astrophysics and philosophy, the true scope of Voyager's mission begins to dawn. It was never simply about reaching the heliopause or measuring particle fluxes. It was about pushing the boundaries of human understanding, about placing a fragment of human awareness in the deep cosmic wilderness to ask an ancient question with new tools. What is the nature of the frontier? Voyager's data expose the cosmic boundary, not as a sharp line, but as a fluid zone of negotiation between competing forces, stellar winds and galactic flows, magnetic fields tangled and transformed, particles of past stellar deaths and newborn stars mingling in untold complexity. This ambiguity destabilizes not only planetary science, but foundational assumptions about the separability of systems and the unity of natural laws. Whatever certainty the solar system was thought to give fades into doubt and wonder. As Voyager's transmission pushes onward, farther from Earth with every second, you realize that the spacecraft itself embodies more than machinery. It is a philosophical beacon, a marker of human audacity faced with vast unknowns. The contradictions in its data, the unexpected magnetic alignments, the particle flux irregularities, the asymmetric heliopause, all narrate a universe simultaneously discoverable and resistant. Here is cosmic awe entwined with a quiet dread, the understanding that even our most precise measurements at the edge of space evoke questions bigger than answers, a reminder of our infinitesimal place within an intricate cosmic web. Voyager whispers that reality might evade final forms, that the universe is less a solved puzzle and more an evolving symphony with movements yet unsung. The implications stretch from the cold void into our very being. If the cosmic neighborhood we inhabit is shaped by such uncertain boundaries, if the edge of the sun's influence is this dynamic and complex, then the very environment that sustains life on Earth is woven from cosmic threads we are only beginning to see. Space is not just an empty backdrop but a participant in our existence. This realization opens an unsettling window onto human vulnerability and cosmic contingency. You see how fragile the conditions for life might truly be, how dependent our planet is on phenomena far beyond common experience, a protective bubble buffeted by invisible forces, changing across timescales that dwarf human history. It is a call for humility, a demand for awe, and a seed for existential unease in the face of the vast unknown. But just as the contradictions grow deeper, the scope of discovery widens still further. Voyager's journey beyond the solar system serves as a gateway, an invitation to reconsider the spatial narrative of humanity itself. The spacecraft's lonely path suggests that even the idea of space as vast and empty is incomplete. Instead, space reveals itself as a structured continuum of magnetic fields, energetic particles, and flowing plasma, each region defined not by emptiness, but by active existential processes. The boundary of the solar system is not merely a scientific curiosity. It is a threshold that connects us to the galactic environment in ways that force reconsideration of what space itself means. The cosmos may be less a void than a vibrant, restless ocean, whose surface humanity has only just begun to touch. This realization cascades into a crisis of cosmic scale. The universe, once thought to be a clockwork contained by immutable laws, begins to feel more like a fluid mystery. Our solar system, the galactic neighborhood, and interstellar space are not isolated or detached realms, but nodes in an entangled web of forces that ripple across scales in unpredictable ways. The contradictions Voyager revealed suggest that our neat compartmentalization of cosmic regions is less a reflection of reality and more a feature of our limited perception. You stand to question whether scientific models, however precise and rooted in mathematics, can ever fully capture the living complexity of space. The very act of observation becomes entangled with uncertainty, shadowed by the possibility that reality itself is stranger and more layered than any equation can confess. At the heart of this cosmic unease lies an unsettling inversion. The farther Voyager travels, the less stable the ground beneath our scientific certainty feels. Where once astronomy was about mapping static stars and predictable orbits, it becomes, at the heliosphere's edge, an exercise in confronting boundary conditions that defy straightforward solutions. This is no longer the domain of only physical measurement, but of epistemological reflection, where science reveals its provisional nature. What we know is framed by what we cannot yet know, and Voyager's data tear at the seams of our cosmic understanding. This fissure is at once a symptom of discovery and an expression of cosmic humility, the realization that exploration is also a confrontation with the unknown depth of the unknown. As the documentary draws onward, this mounting realization grows into philosophical reflection. Voyager's journey stops making sense as merely an engineering triumph and becomes instead a metaphor for humanity's place in an inscrutable universe. You begin to see how the findings at the solar system's edge resonate with age-old questions about the limits of knowledge, the tenuousness of perceived order, and the fragile scale of human existence. The boundary becomes not a line in space but a threshold in understanding, a place where science meets mystery, where certainty dissolves into possibility, and where the universe remains stubbornly, seductively enigmatic. The instruments on board Voyager become storytellers of a cosmic drama whose plot defies simple resolution. And so you stand metaphorically, where Voyager stands literally, at a frontier both physical and metaphysical, where the mechanistic universe folds into questions that challenge the nature of reality itself. The data from the probe are more than cold numbers. They are signposts pointing toward a universe that may defy complete containment by human reason. There is an enormous cosmic irony in this. The tools designed to confirm our models instead expose their inadequacy. The boundary between known and unknown has shifted, and as Voyager moves outwards forever, it takes with it a fragment of our certainty into the dark, leaving behind a quiet echo of wonder and disquiet. This is the paradox Voyager embodies, a monument to discovery that fractures our sense of finality. By the end of this long journey, you are left with a question as vast as the space Voyager explores. Is reality itself a layered mystery, forever resisting comprehensive understanding? Is the universe a book whose pages we can read only partially, always missing key passages with passages that rewrite previous chapters? Voyager's voyage beyond the heliopause proves that science does not always answer questions with neat finality. Instead, it opens doorways to deeper uncertainty, inviting us to reimagine our cosmic story not as a closed tale, but as an evolving discovery, fraught with contradiction and wonder. In this unfolding narrative, Voyager stands as both pioneer and provocateur, a vessel that carries humanity's longing into the darkest reaches of space, reminding us that the cosmos is stranger and more profound than even our most elegant theories confess. This is the deeper meaning of Voyager's discoveries at the edge of the solar system, not just the physical or scientific revelations, but the invitation to embrace unfamiliar complexity, to accept that the universe is a restless, living boundary where certainty always yields to mystery. The spacecraft's steady stream of data challenges us not only to refine our models, but to confront the existential implication that the cosmic frontier may remain forever open, perpetually reshaping our understanding of place, existence, and knowledge itself. Your journey beyond the universe ends not with answers, but with questions that beckon you to continue the voyage in your own mind, towards a horizon where science and wonder meet, where discovery deepens unease, and where the ultimate reality unfolds on its own unknowable terms. The first sign that Voyager had reached something truly extraordinary was not a dramatic visual, because no camera could look into this kind of darkness and return an image of the boundary itself. It was a measurement, a sudden and stubborn shift in the behavior of charged particles, as if the spacecraft had passed through a curtain woven from invisible currents. The solar wind dropped away. The population of lower energy particles changed character. Cosmic rays increased. The surrounding environment no longer behaved like the sun's domain, even though the transition did not announce itself with the kind of sharp theatrical edge that human intuition prefers. It was subtler than that and therefore more unsettling. Nature had not painted a line. It had layered one reality over another until the distinction between inside and outside became a matter of physics, not appearance. That is the first deep contradiction Voyager revealed. The edge of the solar system is real, but it is not simple. The heliopause is often described as the place where the solar wind meets the interstellar medium, but even that phrase hides the problem. Meets suggests two stable entities encountering one another at a border. In truth, what Voyager encountered was a region shaped by pressure, charge exchange, magnetic alignment, turbulence, and the slow statistical negotiation of particles moving at enormous speeds. The solar wind does not end as a wall. It compresses, slows, and finally disperses into an environment already structured by the local interstellar cloud. Neutral atoms from outside drift inward. Solar particles flow outward. Some exchange electrons. Some reflect. Some scatter. The boundary is not a door. It is a process. And once you understand that, you begin to see why Voyager's data were so important. They showed that the sun's influence is not terminated by a single event, but dissolved through a broad and complicated transition zone whose thickness and shape depend on conditions we are still learning to model. The contradiction is small in wording and enormous in consequence. For the scientists tracking Voyager, every new signal carried the risk of collapse for a cherished expectation. If the heliosphere were symmetrical, then the boundary should behave predictably in every direction. But Voyager and its twin, moving on different trajectories, suggested otherwise. The heliosphere is distorted, compressed in some directions and stretched in others, more like a moving organism than a static shell. The reason is partly simple and partly deeply complex. The sun itself is moving through the galaxy. The local interstellar magnetic field pushes against the heliosphere, The interstellar medium is not uniform. Solar activity varies. These factors combine into a three-dimensional structure no textbook diagram can fully capture. The result is a solar boundary that does not merely mark the edge of our system, it records our motion through the galaxy, like a scar showing the direction of our passage. In other words, the heliosphere is a history written in plasma, and Voyager is one of the few readers capable of touching that page. That history becomes stranger when you look closely at the behavior of the magnetic field. One of the most famous surprises from Voyager was the apparent continuity, or near continuity, in the direction of the magnetic field across the heliopause. This did not mean the sun's magnetic field simply extended forever. It meant the boundary behaved in a way that was not anticipated by the most straightforward models. Some researchers interpreted the observations cautiously, arguing that the local interstellar field may align more closely with the solar field than expected because of large-scale geometric effects, not because the fields are truly the same. Others pointed out that the data were limited, and that the outer heliosphere is so hard to sample that every explanation must be held lightly. But the larger implication remained. The edge was not delivering the neat discontinuity many had imagined. Instead, it was revealing a continuity of influence, a blending at the border that suggests space itself often resists the kind of binary separation humans prefer. Inside and outside are not always opposites. Sometimes they are phases of the same relation. The cosmic ray measurements sharpened the unease. Voyager found that galactic cosmic rays rose sharply as the probe moved beyond the heliopause, confirming that the heliosphere had been acting as a barrier against a great deal of high-energy interstellar radiation. But the barrier was not absolute, and the rise in cosmic rays was not merely a technical curiosity. It showed that the solar system's protective cocoon is porous, dynamic, and influenced by broader galactic weather. This matters because cosmic rays shape the radiation environment of planets, spacecraft, and possibly even biological evolution. The sun is not only a source of light and warmth, it is also a gatekeeper, regulating how much of the galaxy's harsher energy reaches us. Voyager made that gatekeeper visible by allowing us to quantify what crosses the threshold when the gate opens wider. The disturbing implication is that our planetary environment is less insulated than we would like to believe, and that the conditions of life may depend on a boundary whose stability is far from guaranteed. That realization extends the scale of the story beyond physics and into a deeper kind of vulnerability. Earth is not isolated inside a cosmic fortress. It resides in a system exposed to fluctuations from both the sun and the surrounding galaxy. Over long timescales, changes in the heliosphere may modulate radiation levels enough to influence atmospheric chemistry, cloud formation hypotheses, and perhaps even the probability of biological stress. The science here remains careful and provisional, but the logic is inescapable. The very architecture of the sun's protective bubble may be one of the hidden environmental factors shaping life's long history. If the heliosphere compresses under certain galactic conditions, cosmic rays can penetrate more easily. If the solar wind weakens, the shield thins. Voyager did not prove every speculative connection, but it made the larger framework unavoidable. We live inside a system whose boundaries are not merely astronomical, they are existential. There is a kind of loneliness in this, not emotional loneliness, but structural loneliness. The solar system is a local arrangement inside a galaxy that is itself only one component of a universe whose scale is almost impossible to inhabit in thought. Voyager's path reminds us that our world is encircled by layers of invisible context. First the atmosphere, then the magnetosphere, then the solar wind, then the heliosphere, then the interstellar medium, then the galactic field. At every level, protection and exposure are entangled. Every boundary is both a shield and a passage. And every passage reveals that our sense of being at home in the cosmos rests on a stack of contingent conditions. The edge Voyager crossed is therefore not just far away, it is a mirror. It reflects how fragile every scale of stability really is, from planetary climate to the larger architecture of interstellar space. Once that insight settles in, it becomes difficult to keep the story confined to astronomy. Because what Voyager discovered at the edge of the solar system is not simply a set of numbers or a boundary shape. It is a demonstration of how science advances into regions where the universe refuses to be summarized too quickly. Every model of the heliosphere is a translation of reality into manageable language, and every Voyager measurement is a reminder that translation is not the same as possession. You can describe the outer solar system with equations, but you cannot make it simple. You can map the heliopause, but you cannot freeze it. You can infer the interstellar medium, but you cannot erase its complexity. This is where the story begins to touch philosophy in an uncomfortable way. If the universe at the edge of our home system is already this resistant to closure, then perhaps the deeper truth is that nature is not meant to be fully domesticated by explanation. The outer solar system becomes, in this sense, a laboratory for humility. It teaches that knowledge is not a monument built once and secured forever. It is an ongoing negotiation with the unknown. Voyager's data changed the boundary from a diagram into a living question, and that question now extends far beyond the spacecraft's own path. Future interstellar probes will need to cross the same threshold and confront the same variability, but perhaps with better instruments and more refined expectations. Even then, they will likely find that the heliosphere's edge is not a single revelation but a layered encounter, one that depends on direction, time, and the state of the sun itself. Interstellar travel, if humanity ever pursues it seriously, will not begin with a dramatic leap into emptiness. It will begin with understanding this complex border, because the region between stars is not empty at all. It is active, it has structure, it has consequences, and so the implications widen again. If the boundary surrounding our system is dynamic, then the galaxy must be understood not as a static backdrop, but as a participant in our local cosmic environment. The sun moves through interstellar clouds, and over immense timescales, it will enter regions with different densities, magnetic properties, and radiation pressures. That means the heliosphere itself may evolve as the sun's galactic surroundings change. The edge of our system is therefore historical in a deep sense. It is a record of where we are in the galaxy's larger flow, and it may not remain the same for long periods of cosmic time. Voyager has shown us a frontier that is not fixed but conditioned by motion. The border of home is not carved into stone. It is negotiated by drift, by force, and by the invisible geometry of galactic space. At this point, you may notice a troubling pattern. The more precisely we observe the edge of the solar system, the less stable our conceptual language becomes. End, boundary, outside, and inside all start to feel inadequate. The heliosphere is neither a fortress nor a veil, neither a shell nor a void. It is an interface. But even that word may be too clean because it implies a neat exchange, a tidy surface where one domain hands off to another. Voyager suggests something messier, a continuum of changing dominance, a boundary region where the sun and the galaxy overlap in a physical argument that never fully resolves. This is the kind of discovery that should expand the mind, and it does, but it also creates a subtle distress, because it forces us to admit that some of the most fundamental structures in space are not as legible as we would prefer. Reality is not obliged to become clearer simply because we have named it. This matters especially when we speak of interstellar travel, because Voyager is not just a scientific instrument, but a rehearsal for the future. Any craft leaving the solar system will first have to survive this transition: the particle showers, the magnetic irregularities, the cosmic radiation increase, the uncertain structure of the heliosphere, and the variability of the interstellar medium beyond it. A ship heading for another star would not depart from a calm border, but from a complex shifting environment whose physics must be understood to avoid misjudging risk. The practical implications are immense. Shielding, navigation, electronics, and human survival would all depend on a more precise understanding of the outer solar system than we possess today. Voyager has already demonstrated that the threshold is harsher and stranger than the old diagrams implied. For future travelers, knowledge of that threshold may be the difference between success and silence. Yet the more you think about future travel, the more the story of Voyager begins to resemble something larger than engineering. It becomes a story about how humanity imagines the unknown. We often picture the universe as waiting to be crossed, measured, and eventually mastered. But the edge of the solar system tells a different tale. It tells us that the unknown is not passive. It interacts, it shapes, it pushes back. The heliopause is not just a place we go through. It is a condition we must understand on its own terms. And once that idea takes hold, it becomes difficult to ignore its philosophical weight. Maybe the universe is not a place we will one day finish mapping. Maybe it is a structure whose meaningfulness increases as our certainty decreases. Voyager's legacy is therefore not only one of distance achieved, but of confidence transformed. There is a final irony here. Voyager was launched to study the planets, yet its deepest significance lies in what it revealed after the planets were long gone. It became, without intending to, a probe of the boundary between worlds, between stellar environments, and between assumptions and evidence. It found that the solar system's edge is a place where the invisible becomes consequential, where plasma physics becomes a story about shelter and exposure, and where magnetic geometry becomes a clue to our place in the galaxy. The spacecraft did not just leave home. It made home appear more fragile by showing how much surrounds it. That is what turns the mission into a kind of cosmic mirror. The farther Voyager travels, the more it reminds us that we are never standing at the center of stability. We are always inside a larger and more uncertain structure, and perhaps that is why Voyager continues to matter so deeply, even now, even in an age with more powerful telescopes and more sophisticated simulations. It speaks from the edge, from the threshold where our theories meet the resistance of reality. It tells us that the solar system is not ending in a neat line but dissolving into a complex interstellar conversation. It tells us that the galaxy reaches into us as much as we reach into it. And it tells us, with the quiet authority of data transmitted across unimaginable distance, that the universe is not obligated to present itself in the form of human comfort. What it offers instead is something more powerful and more unsettling, a chance to see that certainty is provisional, that boundaries are alive, and that the edge of our solar system may be one of the first places where reality reveals just how much it still refuses to be complete. By the time Voyager was sending back its most consequential measurements, the mission had already passed into a kind of scientific legend, but the data itself remained stubbornly concrete. Counts, curves, variations, and shifts in intensity that did not flatter anyone's theories. That is part of what makes the story so powerful. There is no mystical embellishment required, no invented spectacle. The numbers themselves are strange enough. They show a region where the density of the solar wind drops, where the plasma environment changes character, where particles from outside the solar system begin to dominate the local radiation field, and where the instruments on board Voyager can still, across billions of kilometers, register the difference between one cosmic regime and another. The model said the sun's bubble would end. The discovery said the end was more complicated than the idea of an end. The contradiction is not theatrical, it is structural. To understand why this matters, you have to imagine what scientists thought they were looking at before Voyager crossed the boundary. The heliosphere was often pictured as a smooth, expanding bubble, spherical in concept if not in exact form, inflated by the solar wind and pushed back by interstellar pressure. It was an image that made intuitive sense. A star blows outward, the galaxy pushes inward. Somewhere in between, a boundary forms. But nature tends to reject our most comfortable metaphors if they are too tidy. Voyager found that the heliosphere's shape is influenced by the sun's motion through the local interstellar cloud, by the magnetic orientation of nearby space, and by the varying strength of the solar wind over time. The bubble is not merely drifting, it is being sculpted. This means that the solar system is not only surrounded by an exterior, but constantly negotiating with it. The edge is an argument in progress. Once you see the boundary as an argument, the anomalies become more interesting. Why did the magnetic field appear to change less dramatically than expected? Why did the particle populations evolve in ways that complicated clean separation between inside and outside? Why does the heliosphere's edge seem to act less like a wall and more like a porous membrane? One explanation is charge exchange, in which neutral atoms from the interstellar medium interact with solar ions, producing energetic neutral atoms and changing the local plasma dynamics. Another is the possibility that the interstellar magnetic field is shaped in such a way, on large scales, that it aligns more closely with the field inside the heliosphere than simple models would predict. The science is real, precise, and still incomplete, but the implication is what lingers after the technical details fade. We are dealing not with a boundary that closes reality off, but with one that lets reality leak through. That leak is visible in the cosmic ray data, which act almost like a confession from the broader galaxy. As Voyager moved outward, the intensity of galactic cosmic rays increased, especially for particles that had been suppressed by the heliosphere's shielding. These particles are not benign. They are remnants of stellar violence, accelerated in the shock waves of supernovae and other energetic astrophysical events. They carry the imprint of destruction across great distances. When Voyager detected them more strongly beyond the heliopause, it was effectively hearing the universe's high-energy background emerge from behind the sun's protective curtain. The implication is not only that the solar system is exposed to galactic radiation, but that the galaxy itself is a dynamic engine of invisible energy. We are living inside the aftermath of cosmic catastrophes we did not witness, and Voyager has become one of the few witnesses available. The question then expands. If cosmic rays intensify beyond the heliosphere, and if the heliosphere itself changes with solar activity, then the radiation conditions in the solar system are not fixed but variable. This creates a layered picture of cosmic weather that extends far beyond ordinary weather on Earth. Over long periods, the solar wind modulates the heliosphere. The heliosphere modulates cosmic ray penetration, and cosmic rays may in turn influence atmospheric chemistry and possibly biological stress. None of this should be overstated beyond the evidence, but the framework is sobering enough without exaggeration. The environment that nurtures life on Earth sits inside a chain of dependencies, stretching from nuclear processes in distant stars to the pressure balance at the edge of our own sun's domain. Voyager's discoveries make that chain visible. They reveal that our home is not a sealed sanctuary. It is a region of negotiated exposure. There is a temptation when speaking of such things to drift into poetry and lose the science, but the science itself is already poetic in its consequence. Voyager measured temperatures, densities, particle speeds, and field strengths in a place no human has touched. It confirmed that the heliopause exists as a crossing into a different plasma environment. It showed that the solar system's reach is immense, but finite. It also demonstrated that the interstellar medium near us is not an abstraction. It is a real, measurable substance with its own temperature, composition, and magnetic texture. In some sense, Voyager turned the edge of the solar system into a laboratory without walls, where the boundary between solar and galactic physics is observed in real time. And yet, even there, in the language of plasma equations and particle fluxes, the universe seems to resist closure. We can quantify the interface, but not domesticate it. The more precise the data become, the more unsettling the unknown appears. This is especially true because the outer heliosphere is one of the least accessible environments in astronomy. We cannot send crews there. We cannot station a fleet of probes across every direction to resolve the boundary in full three-dimensional detail. We have only a few lonely messengers, each taking a narrow path through a vast and variable region. So every conclusion must be cautious, and every model must be treated as provisional. This is not a weakness of science. It is one of its most honest features. Still, honesty can be unsettling when it reveals how much of the universe remains inferred rather than directly seen. Voyager did not give us a final answer. It gave us a better question. What else hidden in the apparent emptiness beyond the sun has been shaping our cosmic neighborhood all along? That question grows even more serious when we think about the larger galactic environment. The sun is traveling through the Milky Way, and the heliosphere is not stationary within that motion. It passes through interstellar clouds of varying density and composition, each capable of reshaping the boundary between solar influence and galactic space. In the far future, or even the distant past, the system surrounding Earth could be more compressed or more expanded depending on the surrounding medium. This means that the boundary Voyager crossed is not just spatial, it is temporal. It is a snapshot of a living relation between the sun and the galaxy at this specific epoch in cosmic history. To say that Voyager reached the edge of the solar system is true, but incomplete. It reached the edge as it exists now, under these conditions in this part of the Milky Way. Amid this particular pattern of fields and flows, the boundary is not a monument, it is a moment. Moments like that are easy to miss if you are looking only for dramatic endings. But science often works by exposing the fact that endings are rarely absolute. The sun's domain does not stop and then abruptly surrender to emptiness. It fades, interacts, and transforms as it gives way to interstellar space. This is why the term edge of the solar system can be misleading if taken too literally. The edge is thick. It has weather, it has gradients, it has memory. Voyager's measurements suggest that the transition region may contain layers of shocked solar wind, helios heath plasma, and mixed particle populations that evolve over enormous distances. The hidden contradiction, then, is that the boundary is real enough to matter but diffuse enough to frustrate every attempt to define it with a single phrase. We expected a frontier. We found an ecology of plasma. That ecology is not peaceful. The solar wind, though thin, carries mass, momentum, and magnetic structure outward at supersonic speeds until the termination shock slows it. Beyond that point lies the helios sheath, a turbulent region where particles pile up and the influence of the sun weakens. Beyond the helios sheath lies the heliopause, where the interstellar medium asserts dominance. This layered architecture means that Voyager was not simply crossing a line, but traversing an entire atmospheric sequence at cosmic scale. Each zone has its own character, and each one rewrites the assumption that space is empty. The heliosphere is a kind of weather system stretched across billions of kilometers, and Voyager became the first instrument to report from its outermost storms. That alone would be enough to make it important. But the more profound discovery is that the system's complexity seems to increase right where we expected it to simplify. Perhaps that is the central lesson of the story so far. Simplicity is often an illusion created by distance, and distance is exactly what Voyager has conquered. From Earth, the outer solar system looks faint, quiet, and nearly abstract. Up close, by proxy through data, it reveals boundary crossings, particle accelerations, magnetic drifts, and spatial asymmetries that refuse to obey our instincts. The farther we go, the less simple the universe appears. This should not be read as failure. It is a measure of depth. The universe is not difficult because it is broken. It is difficult because it is rich. But richness can feel like threat when it breaks our expectations. That is why Voyager's findings do not only educate us, they unsettle us. They ask us to accept that the edge of our cosmic home may be more foreign than the emptiness beyond it. And beyond that edge, the interstellar medium extends into the broader architecture of the Milky Way, where enormous structures govern the passage of matter and energy on scales we struggle to imagine. The local bubble, the cavity of lower-density material surrounding the Sun, is itself a product of ancient supernovae and stellar winds. Voyager's journey has made us aware that we are living inside the remnants of previous cosmic violence, inside a region carved out by events that occurred long before human history and will continue to evolve long after it. This realization stretches the scale of the story from one spacecraft to the history of the galaxy itself. Our Sun is not isolated. It is embedded in a legacy. The edge it maintains is shaped by the echoes of exploded stars, and that makes the heliopause feel less like a frontier and more like a conversation across generations of matter. When you think about it that way, the spacecraft's loneliness becomes almost unbearable. Voyager moves through a medium that has no human presence, no air, no sound, no immediate witness. Yet every particle it measures is part of a story billions of years in the making. The hydrogen atoms drifting through the local interstellar cloud may have been heated by old shocks, influenced by magnetic reconnection, or filtered through interstellar turbulence long before they encountered the heliopause. The cosmic rays arriving from far beyond the solar system may carry energies from distant astrophysical catastrophes. Everything out there is connected to everything else by invisible chains of cause. Voyager gives us only the last visible link in that chain, and even that is enough to overturn a simplistic picture of the universe as empty and inert. It is not inert. It is saturated with consequence. The final contradiction, then, is this. The more we learn about the edge of the solar system, the more that edge begins to implicate the whole universe. What seemed local becomes galactic. What seemed like a boundary becomes a dynamic interface. What seemed like a science story becomes a question about the structure of reality itself. Voyager did not merely discover where the Sun's influence weakens. It showed us that weakness, strength, protection, and exposure are not absolute states, but relationships that depend on scale and context. This is the kind of finding that leaves a lingering discomfort, because it suggests the universe may never present itself in fully finished form. There will always be more structure behind the structure, more boundary behind the boundary, more unknown behind the answer we just earned. And so we arrive at the deepest unease of all. If the edge of our solar system is this complex, this layered, this resistant to final interpretation, then what does that say about the rest of existence? Perhaps our models are not wrong so much as incomplete in principle. Perhaps the universe cannot be fully compressed into human language, because language itself evolved for survival at small scales, not for mastering the shape of interstellar plasma or galactic magnetism. Voyager's data do not humiliate science. They enlarge it, but they also remind us that each expansion of knowledge opens a wider border of uncertainty. The farther we go, the more the cosmos reveals that it is not merely vast, it is structurally elusive. And that is where the story leaves us for now, standing at the edge, looking outward, and discovering that the universe is not just beyond us. It is beyond the kind of certainty we hoped would one day contain it. When Voyager's instruments began to report the subtle thinning of the solar wind and the rising pressure of the interstellar medium, the measurements did more than confirm a boundary. They exposed the Sun's sphere of influence as something negotiated rather than absolute. That distinction matters because it changes the meaning of home on a cosmic scale. Home was once imagined as a region the Sun controlled, a bright island surrounded by dark water. But Voyager's data showed that the surrounding sea is already pushing in, threading through the outer layers, blending particles and shaping the boundary from outside as much as from within. The model said the Sun's domain would end cleanly. The discovery showed an interface. The contradiction widened, and with it came a more unsettling truth. What we call the edge of our world is not a finish line, but a conversation between systems of matter and energy that never fully stop speaking. That conversation becomes especially strange when you follow the particles themselves. Solar wind is not simply wind in the everyday sense. It is a plasma flow, a stream of ionized matter carrying magnetic fields outward from the sun, and when it meets the interstellar medium, the interaction is governed by plasma physics rather than by ordinary fluid intuition. Voyager's measurements helped reveal how the flow decelerates at the termination shock, how it piles up in the heliosheath, and how the heliopause forms where solar pressure is finally balanced by interstellar pressure. Yet even this elegant sequence is not the whole story. Neutral atoms can slip through magnetic boundaries. Charge exchange can alter particle populations without announcing itself in a dramatic visual event. Magnetic field lines can drape and reconnect in ways that alter the geometry of the boundary. What looks like a simple edge from a distance becomes a deeply engineered landscape at close range. And the more you learn, the more you realize the universe hides its architecture in transitions rather than in objects. Voyager 1 and Voyager 2 each traversed different paths, and that difference itself became a clue. The heliosphere is not uniform in all directions. It is shaped by the sun's motion through the local interstellar cloud and by the orientation of the galactic magnetic field. One probe crossing in the north, the other in the south, told scientists that the frontier is not symmetrical and may even be lopsided in ways that reflect the broader conditions of the sun's galactic neighborhood. The result is a structure that behaves less like a perfect bubble and more like a moving weather balloon pressed unevenly by invisible currents. This asymmetry is scientifically useful and philosophically disquieting. Useful because it gives us insight into the physics of the boundary. Disquieting because it means our cosmos is not arranged for our convenience. The sun's protection is contingent, directional, and forever subject to the pressures of an environment we only partially see. The magnetic field data sharpened the unease because magnetism is where intuition often fails first. We tend to think of space as empty and a field as something superimposed upon emptiness. But Voyager showed a frontier where the magnetic environment is part of the boundary substance. The interstellar magnetic field does not merely lie beyond the heliopause like a background property. It participates in the heliosphere's shape, its distortions, and possibly its unexpectedly smooth transitions. In some regions, the field may be oriented in ways that partially align with the solar field, blurring the expected discontinuity. That doesn't mean the sun and the galaxy share the same magnetic identity. It means the universe can produce continuity where we anticipated rupture. It is precisely this kind of result that unsettles model makers. A boundary that should have been obvious turns subtle, and a subtle boundary becomes hard to narrate. Yet the data refuse to simplify for the sake of our comfort. Then there are the cosmic rays, which behave like the universe's distant memory arriving at the edge of our system. These particles are born in violent astrophysical environments. Shock waves from supernova remnants, jets from compact objects, turbulent acceleration zones in the galactic medium. Voyager detected the increase of these particles as the heliosphere's shield weakened, and with them came the recognition that the solar system is constantly being bathed in a broader cosmic influence. The phrase cosmic ray sounds abstract until you realize it means energy from ancient stellar death, traveling through space and eventually meeting our instruments. The increase beyond the heliopause confirmed not only the crossing into interstellar space, but also the role of the heliosphere as a modulator of the radiation environment around planets. The disturbing implication is easy to miss if you are not listening closely. Earth's cosmic exposure is not fixed. It depends on a shield whose size and strength are not guaranteed. That makes the story larger than Voyager, larger than the heliopause, larger than even the solar system's map. The question becomes whether our planetary habitability is tied to a dynamic boundary, whose state changes over time as the sun moves through the galaxy. It is one thing to say that Earth is in the habitable zone around the sun. It is another to recognize that the local cosmic environment around the sun is also part of what makes Earth livable. If the heliosphere contracts during certain epochs, cosmic rays may penetrate more deeply. If the surrounding interstellar medium becomes denser or more magnetically complex, the bubble may change shape. The evidence remains cautious, but the logic is profound. We are not only inhabitants of a planet orbiting a star, we are inhabitants of a moving plasma system nested inside a galaxy, and that nesting carries consequences that may echo through climate, atmospheric chemistry, and biology over immense spans of time. At this stage, the story stops being only about exploration and becomes about dependency. We depend on the sun. The sun depends on its place in the galaxy. The galaxy depends on structures forged by gravitational collapse, stellar evolution, and ancient explosions. Voyager, in crossing a boundary that had once seemed abstract, exposes those dependencies in their rawest form. There is no isolated scale. Everything touches everything else, even when the touch is indirect, delayed, and invisible. This is perhaps the most unsettling idea of all, because humans are built to imagine clear separations, here and there, inside and outside, cause and effect. But the universe seems to operate by gradients, permeabilities, and continual exchange. The boundary at the edge of the solar system is not an exception to that rule. It is the rule made visible, and yet Voyager's observations did something more than expose dependence. They revealed the incomplete nature of our language for describing it. We say boundary, but the heliopause is not a wall. We say vacuum, but interstellar space contains gas, dust, magnetic structure, and energetic particles. We say empty, but empty is only a word for the limits of our senses. Voyager's data force a more careful vocabulary, one that respects what the universe actually is rather than what our metaphors would like it to be. That change in language is not trivial. It marks a change in posture. Instead of assuming the cosmos will fit our categories, we begin to recognize that our categories are provisional maps drawn across an active and often resistant reality. The edge of the solar system thus becomes a lesson in intellectual discipline. Do not mistake naming for understanding. There is also the practical matter of interstellar travel, which often enters the conversation as if it were a clean future dream. If humanity ever sends crewed vessels beyond the solar system, those travelers will not depart into nothingness. They will have to pass through a region of complex plasma interactions, rising cosmic radiation, and uncertain environmental conditions that Voyager has only partially mapped. Shielding requirements would be severe. Navigation would require careful attention to the local structure of the heliosphere and the interstellar medium. Communication delays would be enormous, yes, but the more immediate issue is physical exposure. Spacecraft systems must survive the transition from solar dominance to galactic environment, and any human passengers would need protection from a radiation regime that changes as the ship leaves the sun's cocoon. Voyager has made interstellar travel less romantic and more real. That is a gift, because reality is what permits survival. And still, even the practical implications are haunted by the philosophical ones. If a machine can carry our curiosity to the boundary and return with evidence that undermines tidy expectations, then what does that say about the limits of explanation elsewhere? We may eventually map more of the heliosphere. We may simulate it more accurately. We may send new probes with better sensors, better trajectories, and better models. But every advance will likely expose another layer of complexity, because the universe does not seem arranged around our need for closure. It is not hostile. It is not friendly. It simply is, and its isness appears to exceed any single framework. Voyager therefore becomes more than a probe. It becomes a reminder that knowledge is always provisional, and that the deepest truths may appear first as anomalies, not as confirmations. This is where the narrative begins to move from astronomy into existential reflection, because the same pattern repeats at every scale. Model, discovery, contradiction. The model says a boundary is simple. The discovery reveals it is layered. The contradiction implies the model was not wrong in spirit, only insufficient in detail. But once that pattern is recognized, it becomes difficult not to ask whether human understanding itself is structured this way in every domain. Do we always begin with a clean abstraction, only to discover reality's resistance? Do the edges of things always hide more than the centers? Voyager suggests yes. The edge of the solar system becomes a metaphor for all knowledge. Every frontier is thicker than we hoped, and every answer arrives with a shadow attached. That shadow is not merely ignorance, it is the presence of larger context. Beyond the heliopause lies the local interstellar cloud, but beyond that are other clouds, magnetic structures, and the broader architecture of the Milky Way. Beyond the Milky Way lies the local group. Beyond that, the cosmic web. The farther the view extends, the more the universe reveals itself as layered organization rather than a simple expanse. Voyager has not reached the final outside, because perhaps there is no final outside in any human sense. There are only scale upon scale, each revealing conditions that make the previous scale look partial. That realization is both exhilarating and slightly unbearable. It means that reality may be endlessly contextual. It means that the more you know, the more you see the conditions that made your knowledge possible. In this light, the edge of the solar system is almost like a threshold in consciousness. You start with the idea that space is mostly empty, that the sun commands its territory, and that the galaxy begins somewhere out there in a clean break. Then Voyager gives you data, and the data insist on nuance. The heliosphere has shape, the boundary has thickness, the interstellar medium has structure, the magnetic field has texture, the cosmic rays have provenance, and suddenly, the familiar becomes less secure. The universe is no longer an abstract backdrop to human life. It is an active field of forces whose hidden architecture affects the very conditions under which life can exist. That is not a distant curiosity. It is the environment of being. By now, the emotional arc has shifted from wonder into unease because the discoveries are no longer merely impressive. They are destabilizing. A cosmos that was once imagined as expansive but legible now appears vast, dynamic, and resistant to simplification. Voyager's measurements at the edge of the solar system show that the outer frontier is neither empty nor final, but interactive and evolving. The scientific story remains beautiful, but beauty here has a sharp edge. It is the beauty of a system that refuses to be compressed into one's assumptions. The heliosphere teaches that even our closest cosmic boundary is a site of uncertainty. It is difficult not to wonder, then, whether more distant truths will prove even harder to hold. That question is where the final movement begins. Because Voyager's journey beyond the sun is not only a record of scientific achievement, but a rehearsal for a deeper encounter with the unknown. It teaches us how to stand at a threshold without pretending to own it. It teaches us that the universe does not have to look like our models to be real, and it suggests, with quiet force, that reality may always contain more than our frameworks can fully absorb. If the edge of the solar system is this alive with contradiction, then perhaps the universe itself is not a solved object at all, but an ongoing revelation, one that unfolds just far enough to keep us searching, and just hidden enough to keep us humble. Standing with Voyager at the solar system's edge, you confront a striking paradox. The farther the probe travels, the more the cosmos resists definitive closure. Instead of crossing a crisp boundary and passing into pristine interstellar space, Voyager entered a realm of gradations and entwined forces. This transition zone is neither a wall nor a vacuum, but a complex interface in which solar and galactic influences intertwine, overlap, and reshape one another. Since the earliest theoretical estimates, we hoped for manageable parameters, a neat frontier that science could border and catalog. Instead, the universe offers a liminal expanse, fluid, dynamic, mutable. Voyager's early data disrupted assumptions and continues to challenge the boundaries of knowledge itself. This disruption echoes beyond plasma physics and particle counts. It beckons reflection on how we as humans relate to spaces that defy tidy definitions. The heliosphere once seemed a cosmic fortress and sanctuary, an island in a vast empty sea. Voyager's findings reveal it more as a permeable membrane, ever shifting under the push and pull of invisible currents. That metaphor applies beyond astrophysics. It mirrors the experience of confronting complexity and ambiguity in our own lives. The realization that boundaries are rarely hard lines, more often porous thresholds where certainty blends into doubt. In this cosmic liminal zone, science, philosophy, and existential thought converge. These insights ripple into how humanity imagines its cosmic place. For centuries, the heavens inspired awe and order. The sun was central, and the stars distant, immutable. Voyager refines this picture, emphasizing motion, variability, and interplay. The solar system is not a fixed stage, but a dynamic actor's scene, its contours sculpted not only from inside by solar winds, but also from outside by galactic forces. Our home is not a static locus, but a node in an energetic network, a brief pattern of stability in an evolving galactic landscape. This shifts the human story from conquest and mastery toward participation and belonging in a living cosmos. Voyager's journey continued to reveal the hidden intricacies of this participation. As the spacecraft pushed beyond the heliopause, instruments recorded unexpected fluctuations in magnetic field strength and direction, particle energization, and plasma density. These fluctuations speak to turbulence and reconnection events, phenomena that complicate the simplistic notion of a boundary as a neat division. Instead, the edge of our solar system is characterized by dynamic processes, mixing zones where particles and fields coalesce and reconfigure continuously. Voyager thus exposes not only physical realities but also the universe's resistance to straightforward classification. The magnitude of this resistance becomes clear when considering the limitations of our instruments and trajectories. Voyager processes data from only two discrete unidirectional paths through the outer halo of the heliosphere. This sparse sampling suggests that what we know might resemble seeing only the tip of a vast complex iceberg. The uneven asymmetrical nature of the heliosphere implies that uncharted variations persist in regions Voyager has not yet sampled. Hence, our understanding remains partial, and future missions will be essential to complete the mosaic. Voyager's achievements therefore mark both beginnings and invitations. Beginnings of a new cosmic perspective, invitations to probe deeper into the universe's layered realities. The solar system's edge, in this light, becomes a frontier not just in distance but in epistemology. Voyager teaches that the most profound astronomical discoveries are often those that upend our frameworks and invite us to rethink fundamental assumptions. The spacecraft's crossing revealed that boundaries are not static demarcations, but evolving intersections shaped by multifaceted forces. This underscores a larger truth about knowledge. It is provisional, iterative, and enriched by contradiction. Cosmic complexity does not diminish science. It enriches it by expanding questions and opening new domains of inquiry. The heliosphere thus emerges not only as a physical structure, but as a metaphor for intellectual humility. This intellectual humility echoes in the tensions between observation, theory, and model. Voyager's unexpected data forced scientists to revisit and revise models of the heliosphere, to develop more intricate simulations that incorporate magnetic field anisotropy, charge exchange physics, and turbulence. These advances demonstrate science's capacity to adapt and self-correct, yet they also highlight how each new layer of detail complicates the picture, suggesting that no model may ever perfectly capture the fullness of such a dynamic system. This tension embodies science's beauty and challenge. It is a quest both for clarity and for embracing complexity. On a broader cultural scale, Voyager's revelations touch on humanity's enduring need to define boundaries between self and other, known and unknown, home and wilderness. The spacecraft's struggle to demarcate the heliosphere is a cosmic analog to these human struggles. Boundaries that seem clear at a glance thicken under scrutiny. Zones thought impenetrable prove permeable. Voyager reminds us that the universe may refuse final categorization, reflecting how identity and understanding in any domain often involve negotiation, flux, and paradox. The cosmic becomes personal, as our picture of space mirrors our own being's boundaries. Voyager's data, once interpreted solely through the lens of physics, thus acquire a poetic dimension. They narrate an ongoing dance of forces, an endless interplay between containment and openness, persistence and transformation. The solar system's edge is no longer a terminus but a threshold, an active zone where forces converse, boundaries blur, and certainty gives way to possibility. This turns the spacecraft from a mere machine into a storyteller, a bearer of elegant enigmas transmitted across the vastness. Voyager speaks not only of space but of existence itself, the fragile, vibrant balance of being at the frontier. In contemplating these discoveries, it becomes evident that the universe consists less of neat compartments than of interwoven processes. Voyager's crossing of the solar system's edge is a cosmic metaphor for transition between childhood and adulthood, ignorance and understanding, certainty and wonder. As the spacecraft continues to journey outward into the unknown, it invites us likewise to embrace uncertainty, to cherish questions as deeply as answers, and to take our place amidst the restless, unfolding mystery. The edge of our solar system, illuminated by Voyager's eyes, becomes a symbol of the eternal frontier, the place not just where worlds end, but where wonder begins. Voyager's most enduring lesson may be that the universe is not obligated to present its structure in forms that are easy for us to narrate. At the solar system's edge, the spacecraft encountered a domain where familiar categories began to lose their sharpness. Solar became interstellar, not in a single instant but through a sequence of interactions that made the idea of a clean handoff feel almost naive. The heliopause did not announce itself with spectacle. It emerged through evidence, and evidence is often more unsettling than drama because it cannot be dismissed as merely emotional. It accumulates, it persists, and it quietly dismantles assumptions. What Voyager taught us then is not simply where the sun ends. It taught us that endings in nature are often transitions in disguise. That lesson has consequences for how we think about knowledge itself. Human beings love closure. We want maps with borders, categories with crisp edges, and explanations that fit into a single frame. But the outer solar system refuses that impulse. The more carefully scientists measured plasma density, particle flux, magnetic behavior, and energetic radiation, the more the boundary revealed itself as an evolving system rather than a finished object. This is not a failure of science. It is one of science's greatest successes. By refusing to simplify the boundary beyond what the data allow, researchers preserved the integrity of the phenomenon. They accepted that reality can be exact without being tidy. Voyager's achievement lies partly in making that humility visible. The heliosphere is therefore more than an astronomical feature. It is a case study in how systems persist by interacting with what surrounds them. The sun does not rule its domain by absolute command. It maintains influence through pressure, flow, and magnetic structure, all of which are conditional upon the surrounding galactic environment. This makes the solar system feel less like a sealed estate and more like a living borderland. The sun's bubble is protective, yes, but protection here is relational rather than permanent. It depends on external and internal conditions that vary over time. That means our local space environment is not a backdrop for life, but part of the machinery that makes life possible. Voyager exposed the machinery. Once exposed, the machinery raises unsettling questions about the broader environment of habitability. If the heliosphere modulates cosmic rays and shapes radiation exposure, then it is part of the chain linking the sun's behavior to the conditions on planetary surfaces. Over geological timescales, shifts in the solar wind, solar magnetic activity, and interstellar conditions could alter the level of shielding Earth receives. The evidence for specific biological impacts remains complex, and in some areas unresolved, but the conceptual point is unavoidable. Habitability is not governed by a single factor. It is nested. Earth's life-supporting conditions arise inside a series of protective and permissive envelopes, and one of those envelopes is the solar boundary Voyager crossed. That fact alone changes how we imagine our place in the universe. It also changes how we imagine distance. The edge of the solar system sounds remote, almost irrelevant to daily life. Yet Voyager showed that something so distant can still matter profoundly to the radiation environment that shapes planetary atmospheres and, indirectly, biological systems. That is a recurring theme in astronomy. The most remote structures often have consequences that arrive home quietly and slowly. A supernova in the neighborhood can flood space with particles. An interstellar cloud can compress the heliosphere. A change in the sun's activity can alter our shielding. The cosmos is not arranged by proximity in the way our instincts assume. Distance does not always mean detachment. Voyager reminds us that the farthest things may still be part of the conditions of our existence. There is also a historical dimension to this realization. Before Voyager, the edge of the solar system was mostly conceptual, a place inferred from theory and remote sensing. After Voyager, it became empirical. That shift matters because it represents one of the rare moments in science when a frontier transitions from imagination to measured reality. The spacecraft carried with it a set of instruments designed decades earlier, yet those instruments remained capable of redefining an entire region of space. This is part of the mission's wonder. An object built by human hands in the 1970s and 1980s still speaks with authority across more than 40 years and billions of kilometers. The technology is old, the data are still transformative, and the universe remains larger than the era that launched the probe. Voyager's longevity also lends the story a kind of mythic gravity, though the myth is grounded in engineering. The spacecraft has crossed from one epoch of spaceflight into another, becoming a relic that outlived the assumptions of its own time. In doing so, it has shown that endurance can be as scientifically important as power. A long-lived probe can witness changes that shorter missions never would. It can reveal slow transitions, rare events, and the cumulative behavior of environments that unfold over decades. The heliopause was not discovered in a week or a year. It was inferred through perseverance. That makes Voyager less like a snapshot and more like a chronicle. It records the patient unfolding of a frontier that only yields its shape over time. Time is central here because the outer solar system is not static. Solar activity varies across the 11-year cycle, and the heliosphere responds. The boundary's position, thickness, and particle populations can shift depending on the sun's output and the surrounding interstellar conditions. So even after Voyager crossed the heliopause, the surrounding environment was still changing. This means the boundary is not a final destination, but a moving target. One of the deepest misunderstandings about space is the idea that faraway places are fixed simply because they are remote. Voyager exposes the opposite. Remoteness does not guarantee stability. In fact, the further one goes, the more one may encounter dynamics that are harder to sample and therefore harder to understand. That dynamism returns us to the strange beauty of the heliosphere as a system of layers. Inside, the solar wind dominates. Further out, the termination shock marks where the wind slows. Beyond it, the heliosheath stretches as a turbulent transitional zone. Then the heliopause stands as the rough balance point between solar and interstellar pressures. Beyond that, the local interstellar medium extends, itself textured by density variations, magnetic fields, and remnants of ancient stellar activity. This architecture is not just scientific information. It is a way of understanding that space is active, structured, and relational all the way down. The void we imagine is, in fact, full of conditions. Voyager taught us that emptiness is often a human shortcut rather than a physical description. And that shortcut is costly if we rely on it too much, because it invites false certainty. When we imagine space as empty, we underestimate the forces that shape travel, radiation, and cosmic evolution. When we imagine boundaries as simple, we miss the complexity of transition zones. When we imagine our home system as isolated, we forget how deeply it is embedded in the galaxy's larger environment. Voyager's greatest service may be to break those habits of thought. It forces the mind to move from object-based thinking to process-based thinking, from nouns to verbs, from static maps to active relations. That is a hard shift, but it is the right one if we want to understand not just the outer solar system, but the universe itself. The true astonishment of Voyager is not merely that it crossed a boundary, but that the boundary turned out to be an evolving instrument of revelation. As the spacecraft moved outward, the solar wind diminished, cosmic rays intensified, and the surrounding medium grew legible in ways that no remote telescope could have made fully concrete. The edge of the heliosphere became less a fence than a filter, a place where the sun's influence is translated, reduced, and finally exchanged for a different cosmic regime. That translation is crucial. It means the universe is not divided into sealed territories. Instead, it is stitched together by transitions, and those transitions themselves contain information about both sides. Voyager did not find emptiness at the edge of our system. It found conversation. That conversation is encoded in particles, fields, and gradients, but its meaning extends into the philosophy of observation. We often assume that the most important scientific discoveries will be dramatic, immediate, and visually unmistakable. Voyager's discoveries were none of those things. They were subtle, patient, and cumulative. They required long durations, careful calibration, and the willingness to trust instruments that had been functioning for decades in conditions no one could ever recreate on Earth. This is an underappreciated lesson. The universe frequently reveals itself not through spectacle, but through persistence. A boundary can be real even when it is hard to see. A discovery can be profound even when it arrives without fanfare. The cosmos does not always shout. Sometimes it whispers in flux counts and field vectors. This quiet mode of revelation gives the Voyager story its peculiar emotional force. The spacecraft itself is almost absurdly small compared with the vastness it has entered. A machine built by one species on one small planet now travels through interstellar space, far from every human structure that gave it origin, and yet its signals still return, faint but intelligible, carrying evidence that rearranges our picture of the sun's domain. There is something almost heartbreaking in that contrast. It suggests that knowledge is often carried by fragile things. Human understanding of the universe depends on delicate sensors, on weak radio beams, on the endurance of systems designed by imperfect minds. The grandeur of what is learned is matched by the fragility of the means by which it is learned. That fragility matters because it reveals a deeper truth about our relationship with the cosmos. We do not possess it, and perhaps never will. We sample it, we infer it, we build models that approximate its patterns. But the universe remains larger than our tools, and Voyager's success does not diminish that fact. If anything, it makes the fact more vivid. The more capable our instruments become, the more clearly we see that reality always extends beyond what they can register. This is not a defeat. It is the natural condition of exploration. Every measurement is partial, every map selective, every theory contingent. Voyager's data make this condition visible at the very boundary of our local cosmic home, where the partiality of knowledge feels almost physically embodied in the structure of the heliosphere itself. There is an additional irony here. The spacecraft that taught us so much about the edge of the solar system was never designed to be a permanent philosopher. It was built to explore the outer planets, to fly by worlds, to send home images and measurements, and to continue if possible. Its extended mission became extraordinary because of longevity, luck, and the determination of engineers and scientists who kept listening. This means the most profound revelations often come from systems that outlast their original purpose. In both technology and thought, endurance creates opportunities that planning alone cannot predict. Voyager began as a planetary mission. and became a boundary mission, then a transition mission, then a witness to interstellar space. The universe repurposed the probe by simply continuing to exist longer than expected. The longer it persists, the more Voyager seems to symbolize the tension between human intention and cosmic scale. We launch with goals. The universe replies with complexity. We build models. The universe returns anomalies. We seek completion. The cosmos offers continuation. That tension is visible in the heliopause itself, which is not a single event, but a boundary region thick with processes. It is also visible in the emotional response the mission inspires. People want a final edge because final edges feel narratively satisfying, but the actual edge is dynamic, and that dynamism can feel like a refusal. In truth, it is an invitation, a refusal of false closure and an invitation to keep learning. Learning in this context means accepting that the solar system is embedded in galactic life, not life in the biological sense necessarily, but life in the sense of ongoing motion, exchange, and transformation. The Milky Way is not a static backdrop. It is a medium of evolving structures, supernova debris, magnetic fields, star formation, and dark gravitational architecture. The Sun drifts through this medium, carrying its planets and heliosphere with it. Voyager, by reaching beyond the Sun's cocoon, showed us that the cosmic neighborhood is not empty space punctuated by stars. It is a lived environment of physical interactions on scales so broad that our human sense of place strains to keep up. The universe is less like a set of islands and more like a sea of linked currents. And yet seas have surfaces, gradients, and depths, which is another reason the boundary metaphor never quite works. The heliosphere is not merely a surface we crossed once and for all. It is a volume with structure, influenced by the orientation of magnetic fields and the density of surrounding material. Voyager's north-south differences helped expose that structure, reminding us that the Sun's reach is not symmetrical, and that the interstellar environment itself may be anisotropic. These are technical details, but they carry philosophical weight. Asymmetry is normal. Our longing for symmetry is human, not universal. Nature is perfectly content to be uneven, and Voyager's path through that unevenness is part of why the mission matters so deeply. The scientific community will likely continue refining these models for decades. Future probes may travel in new directions, with better sensors and more precise methods, to map the heliosphere more completely. That prospect is thrilling, but it should not diminish Voyager's unique achievement. The first crossing is always special because it transforms the unknown from speculation into experience. After Voyager, the outer boundary of the solar system is no longer a guess. It is a measured, though still evolving, reality. That shift changes not only astrophysics, but the imagination. It gives us permission to think beyond the known without pretending the unknown is shapeless. We now know there is a structure there. We just do not yet know its full form. And perhaps that is enough to end on for now. The recognition that the universe has form, but not finality. Voyager brought us to a threshold where the Sun's breath gives way to the galaxy's deeper currents, where shielding becomes exposure, and where a local boundary opens onto a larger order. The story is still unfolding, but its central message is already clear. The edge of the solar system is not a wall. It is a passage. And passages by their nature teach us less about where things stop than about how they continue. If you want, I can carry on with the next section and move into the concluding paragraphs. Crossing that passage means embracing a new way of seeing, not as conquerors who claim fixed borders, but as travelers who recognize that every boundary is a gateway. Voyager's journey beyond the solar system challenges us to revise our metaphors and stories about space, from ones of isolation to ones of connection. The cosmos is less a collection of distant objects and more a continuous interplay of forces, energy, and matter on scales both enormous and intimate. This new vision urges humility and openness, qualities essential for future explorers venturing not just outward, but upward in understanding. The human impulse to explore remains strong, fueled by curiosity and the desire to know our place in the vastness. Voyager embodies that impulse, a testament to what small, persistent efforts can accomplish. It reminds us that discovery is often slow and incremental, punctuated by moments of revelation that rewrite entire fields. Yet it also reveals that each discovery often brings new questions, extending the frontier rather than closing it. In that way, Voyager is a symbol of science's ongoing dialogue with the unknown, a process without finality but rich with promise. As we imagine future voyages, whether robotic probes with advanced technology or one day crewed missions venturing outward, we carry with us the lessons Voyager imparted. Preparation must include respect for complexity, readiness for surprise, and the knowledge that boundaries shift and overlap. Understanding the heliosphere's dynamic nature is essential not only for navigation and hazard assessment, but also for grasping how cosmic factors influence planetary environments and life itself. Voyager's legacy, therefore, is both practical and philosophical, spanning the technical and the contemplative. Finally, the story of Voyager extends beyond science into culture and consciousness. The probe's golden record, a message from humanity to the cosmos, reminds us that exploration is deeply tied to identity and meaning. Crossing the solar system's edge is not merely a physical feat, it is a metaphor for venturing into the unknown parts of ourselves and our collective experience. The uncertainties, the ambiguities, and the beautiful complexities revealed by Voyager resonate as a call to embrace the mysteries that surround and inhabit us. In sum, Voyager's passage beyond the heliosphere transforms our understanding of the solar system's edge from a distant frontier into an active threshold, intertwined with galactic forces and reflective of the universe's unfolding complexity. It reminds us that boundaries are not ends but invitations, inviting us to listen more closely, model more thoughtfully, and imagine more expansively. The journey continues, not just for Voyager, but for all who look outward and ask what comes next. In the waiting, in the searching, we find our own passage into discovery. And so the story arrives not at an ending, but at a widening. Voyager, still moving, still transmitting when possible, still bearing the mark of human intention, now belongs as much to the future as to the past. Its journey beyond the heliosphere is a reminder that discovery does not conclude when a border is crossed. Rather, discovery deepens when the border itself proves more intricate than expected. The solar system's edge is not a line that closes a chapter. It is a threshold that opens one. Beyond it lies not emptiness, but relation, not silence, but a new kind of listening. This is why Voyager endures in the human imagination. It is more than a probe and more than a historic first. It is a sign that our finest questions are often larger than the answers we initially dare to seek. The spacecraft's data have rewritten textbook certainty, but they have also done something subtler. They have taught us how to remain open in the face of surprise. That openness is not passive. It is an active discipline, a willingness to let reality exceed expectation without turning away. Voyager models that discipline with extraordinary grace. It shows that the most meaningful journeys are the ones that expand the traveler as much as the map. The heliosphere, once imagined as a simple protective bubble, is now understood as a living, breathing interface between the sun and the galaxy. It is shaped by motion, pressure, magnetism, and time. It shifts with solar cycles, responds to interstellar conditions, and resists reduction to a single static image. In learning this, we learn something equally important about ourselves: that stability is often dynamic, that protection is often relational, and that belonging is rarely separable from exchange. The cosmos does not hand us rigid categories. It offers continuities, transitions, and thresholds. Voyager made that truth visible at the farthest edge of our local home. There is a quiet dignity in that visibility. No fanfare was needed. No monumental rupture announced the crossing. Instead, the evidence accumulated, and from accumulation came certainty. This is the patient logic of science at its best, not the domination of nature, but the careful listening that allows nature to speak in its own terms. Voyager's instruments, though ancient by modern standards, remained faithful long enough to reveal what newer, faster, noisier systems might have missed. In that fidelity lies a lesson for every field of human endeavor. Endurance matters, attention matters, and the willingness to follow a phenomenon wherever it leads matters most of all. So the final image is not of a spacecraft disappearing into darkness, but of a small human-made traveler continuing outward through a vast and textured universe, carrying with it the trace of our curiosity. The edge of the solar system has become, through Voyager, a place of profound insight rather than simple termination. It is where the sun's influence meets the galaxy's reach, where the known dissolves into the not yet known, and where wonder becomes method. If the story has a conclusion, it is this: every frontier is also an invitation. The farther we go, the more clearly we see that the universe is not finished with us and perhaps never will be.